All right, good evening. We are going to use the distance formula and we're going to learn about Pythagorean triples in our lesson today. Before we begin, I'm going to label these points accurately because this is not 3, 2. 3, 2 would be up here. I'm going to change this to negative 5, 2 because it's bothering me. And then this point looks like 4 and we're going up 6. This is 4, 6. Okay, this point right here, 4, 2. And now we can accurately find the distance of AB. So we first need to find the distance of this point here, this line here, this leg. So to do that, I'm just going to take the absolute value of 5, add it to 4, or I can do 4 minus negative 5, which is 9. So this length right here is 9. Same thing here, I'm going to take 6 minus 2, and I get the length of 4. So this leg is 4 and this leg is 9. Now I can use Pythagorean theorem and solve for AB. So I'm going to use c squared equals a squared plus b squared. Because my hypotenuse is AB, I'm going to say AB squared equals 9 squared plus 4 squared. 9 squared is 81, 4 squared is 16, and we add them together and get a total of 97. So right now we have AB squared equals 97. To figure out what AB is, take the square root, and I know now AB is the square root of 97. Cannot be simplified, so I keep that as my answer. Okay, now using the same idea, we're going to derive the distance formula. Okay, this point here is x2, y1. Okay, got to be the same point here, has to be the same y here. So in order to get this length, I'm going to take x2 minus x1. I did the same thing here. I took x2 minus x1, subtracted them. And then to get this length, I'm going to take y2 minus y1. Okay, now this length here, y2 minus y1. This length is x2 minus x1. I'm going to use Pythagorean theorem to find AB. So again, c squared equals a squared, x2 minus x1. Now remember, it's okay to switch to a and b, plus b squared, y2 minus y1. Okay, remember this is my side A, this is my side B. In order to get AB alone, I'm going to take the square root of both sides. So I derive x squared, square root of x2 minus x1 squared plus y sub 2 minus y sub 1 squared. And right here, we just derived the distance formula. Hopefully you learned this last year in algebra, so this isn't too new. But if it is not difficult. So if you find the distance between the 2 points, we are just going to plug the x values in first. It really does not matter, but in our formula of x2 minus x1, you could switch it because you're squaring in the number, so you end up getting the same value either way. So 13 minus 1 are x values, and y2, 3 minus 8, and remember to square it. Remember, parentheses go first, order of operations, so I'm going to take 12 squared and negative 5 squared. After parentheses go exponents, 144 plus 25. Take the square root of 169, and my distance is going to equal 13. Any questions? Similarly, I'm going to do the same thing here. This problem, I'm going to use a triangle. So I'm going to plot A, negative 1, 2, B is 4, 0, and C is 1, 7. Okay, I'm going to connect the vertices. And I'm trying to prove the triangle's isosceles. To do this, I have to find the distance between all points. So I'm going to find first the distance of AB. Okay, so for the distance of AB, I'm going to use these first 2 points. First, the x values, 4 minus negative 1, careful here. It's a negative, so I have two negatives. And 0 minus 2. Okay, this brings me to 5 squared plus negative 2 squared. Okay, 25 plus 4 is the square root of 29. Okay, so I have AB with a length of square root of 29. Let's try AC. Okay, so I'm going to take the square root of now these two. So I'm going to do 1 minus negative 1, quantity squared, plus 7 minus 2, quantity squared. Okay, this brings me to 2 squared plus 5 squared. Looks like I'm getting 4 plus 25, which is the square root of 29. Okay, because the two sides are isosceles, triangle ABC is isosceles. Now if I pick CB, I have to do it again in order to get two sides that were congruent for the same measure. Mr. B's brand new TV is sitting at Best Buy. The dimensions for the TV are 30 by 40 inches. Remember, a TV size is measured diagonally across. So we have a TV sitting at Best Buy. We have 30 inches and 40 inches. Okay, we have to get the measure across. So we have to find this diagonal, which is the hypotenuse. In order to do that, we will do the Pythagorean theorem. Okay, so here is our x, which is actually c. X squared equals 30 squared plus 40 squared. Okay, if you calculate that out, we get x equals 50. So his TV is 50 inches. Okay, this problem could be done much easier without calculating and doing the whole problem if you know the Pythagorean triples. It's very useful to memorize these. Okay, it will save a lot of steps and a lot of time on your tests if you know the triples. So basically, any triangle with sides 3 and 4, the hypotenuse has to be sides number 5. So 3, 4, 5 triangle always works if it's a right triangle. Same thing for 5, 12, 13, 7, 24, 25, and 8, 15, 17. So any multiples of these always work. So 6, 8, and 10 will work. I'm multiplying all these numbers by 2. Similarly, I can multiply them by 3. 9, 12, 15 will work. 12, 16, and 20 will be the hypotenuse. Okay, let's change the color and move on to 5, 12, 13. If I multiply by 2, I get 10, 24, 26, 15, 36, and 39, and 20, 48, and 52. Okay, all these are sides of a right triangle. Remember, the hypotenuse is the largest side. That's very important because triples will not work unless the hypotenuse is the longest side. Moving on, for 7 we have 14, 48, 50. If I multiply by 2, multiply by 3, 21, 72, and 75, and by 4, 28, 96, 100. Again, I can keep going. I can multiply by 5, and I still can continue the triples. And then my last one, 8, 15, 17. Let's multiply by 2. So we have 16, 30, and 34. I also have 24, 45, and 51, multiplying by 3, and by 4, 32, 60, and 68. Again, I can multiply by 5 and keep going. Another triple that we did not mention, but is also useful, is 11, 60, and 61. So you could do that with those three numbers as well. Okay, here's how to implement this without too much trouble. Looking at 525, I can divide them all by 5. So if I divide this by 5, I'm going to get 3. Divide this by 5, I will get a 5. This is a 3, 4, 5 triangle. Okay, so this side 3, 4, 5 triangle, the 4 side goes here. 4 times 5 was going to be 50. I'm sorry, 4 times 5 is 20. What am I thinking? So x is 20 without doing anything. Okay, this one right here, I can divide it, and I can get 13. Divide by 4, I get 12. The other side, what goes with a 12, 13 triangle? Looking back up here, it's 5. So this side is, so if this side is 5, 5 times 4 is 20. 20 must be this side. X is 20 again. The next example. This one is actually divided by 2. If you notice, 7 divided by 2, 3.5. 24 divided by 2, 12. And 25 divided by 2, 12.5. So this is a variation of the 7, 24, 25 triangle. This side is 7. This side is 24. So this side is 25. So if I reverse it, if I divide by 2, x is going to equal 12.5. Okay, and this just makes it easier on yourself so you don't have to do Pythagorean theorem over and over and over again. This question, we just take the numerator. So x 7 over 6, I believe this is 20. And I'm back. Sorry, I had some technical difficulties. So this question right here, this is a 7, 24, 25 triangle. Remember, the 25 must be the hypotenuse because it's the largest side. Here's a 7, which means this side has to be 24. However, since all these numbers are divided by 6, we're going to take 24 divided by 6. Okay, and that can be simplified to the value of 4. So in this problem, x equals 4. And the last one. Be very careful here. This appears to look like a 3, 4, 5 triangle, right, multiplied by 2. However, 5 must be the largest side, or the hypotenuse. Same thing, and this is not the hypotenuse. So this is not a 3, 4, 5 triangle. In order to solve this one, it's not a triple. I have to use Pythagorean theorem. So 8 squared is my hypotenuse. X squared plus 6 squared are my legs. We have 64 equals x squared plus 36. And subtract 36, which leaves me with 28. And I can simplify 28, pull out a 4, 7, which makes it 2 square root 7 is x. That ends today's lesson, and we will see you next time.